So this lesson is going to be about the energy and chemical reactions, and the learning target is to be able to classify chemical reactions based on energy changes and specifically understand what's going on with energy in endothermic and exothermic reactions, which you'll learn what they are in a bit. So when we think about what's going on in a chemical reaction, remember that atoms are being rearranged in this chemical reaction. So we have compounds that we're starting off with. Those atoms are going to rearrange, and on the other side of the chemical reaction, they are going to have new compounds. So there is going to be some bonds breaking at the start and bonds forming at the end. And what's going on with energy here is we have to put energy into this reaction in order to get those bonds, those original bonds, to break, right? The compounds that we're dealing with are stable the way they are. They were formed because they're stable. And so to put them into a form that's less stable, where the atoms are able to bond with other atoms and not the original compounds, we have to put some energy in to get that going. And so the energy is absorbed in those compounds in order to break those bonds. But then those atoms are going to rearrange and they're going to form new bonds. And because they'll be more stable as compounds, as formed compounds than they are as individual atoms, there's going to be energy released when those new bonds are formed. What you need to remember is that we have to put in energy to break bonds, and then we get some energy back out once those bonds are formed. Okay? So that's what's going on with some of the energy changes in a chemical reaction. We're going to show a little bit of a simulation here from ACS that shows this. And you've seen this before if you've been watching the videos up until now. We have methane and oxygen that we're starting off with. We put some energy in order to break those bonds, again, to get our atoms so that they're ready to form new compounds. Again, we put energy in that breaks those bonds for our oxygen. And when those atoms rearrange and they form water, we've got oxygen and our hydrogens. They form these compounds, and you saw that energy take off. And so watch this. When carbon dioxide forms, we get some energy coming back out of that because they're more stable. And we can see what's going on here. We have energy going in to break these bonds like we saw, and then we've got our energy coming out on this side. And this reaction is called exothermic. You can see that there's more energy coming off on our product side than there is going in on a reactant side. And so what would happen here is this reaction would start to heat up its surroundings, whether it's happening, well, this is methane and oxygen, so this would just be basically lighting something on fire. It'd be heating up the air around there, and there'd be that energy given off, and we could actually feel that. And this is called exothermic. Exit, we're giving off energy. We're giving off more energy than what it's taking to break those bonds. And so in exothermic, there's energy released, and exothermic feels hot. So our energy released is greater than our energy that's being absorbed here. Again, if I break these bonds, I'm putting some energy in. I have to do that in order to break those bonds, but I'm getting out much more energy than what I'm putting in. And just another visual of this happening. My exothermic exit, I'm losing more energy than what I'm putting in. And so an exothermic reaction would feel warm in this case, because it's going to heat up its surroundings. We could have the opposite happen with an endothermic reaction, where the energy that we're putting in, you probably saw that energy was pretty big there to break those bonds. So we have to put a lot of energy in, and we're still going to get some energy out when we form these bonds. But overall, we had to put in way more energy than what we got out of it. And so this reaction is taking in energy, these compounds. And so this is called an endothermic reaction, meaning that there's more energy going in than there is coming out. We would consider this reaction to be absorbing energy. And so this would feel cold because the energy from the surroundings, the environment, is going to be taken up into this reaction to break those bonds. So our endothermic reaction, because energy is absorbed, is going to feel cold. Okay, so our exothermic and endothermic are exact opposites of each other. Now, if we were going to look at the energy curves here, if we were going to look at the energy of the reactants and products in this reaction, our endothermic reaction, because we're taking in more energy than what we're giving out, our reactants have less energy than our products because we're taking in more energy than we're giving off. And so our products, our finals, have more energy. You can see that stored chemical energy would go up on this axis as we go up. And as the reaction takes place, again, we would absorb some energy. But our exothermic reaction is going to be the opposite. Our reactants have a lot of energy, and they're giving off more energy than what is taken to break those bonds. And so our products end up with less energy than our reactants. This difference in energy from our reactants to our products is the energy that's given off in an exothermic reaction. Remember, these feel warm, so we're giving off that energy. This energy right here is the energy that's absorbed by the reaction overall, and is why these endothermic reactions feel cool. So that activation energy, that energy that we needed to put in initially to break the bonds, because the reaction is not going to happen if those bonds don't break. And so that activation energy is the energy that it takes to get this reaction started. That's what we would call it. And that's that energy that it takes for those bonds to break. And once those bonds are broken, that energy is put in, the atoms are free to rearrange and form new compounds. And so the activation energy is the energy that it would take to start a chemical reaction. And you can see here how this whole picture looks. So our energy of our reactants, we start off with a certain amount of energy, right? We put in some energy in order to break those initial chemical bonds. That's our activation energy, what it takes to get this thing started. Once we put in that energy, this reaction is going to take place. The atoms are free to start forming new bonds. And again, when they're forming new bonds, they're becoming more stable, and so they are going to be giving off some energy. And so the energy of this whole reaction, these compounds, overall will go down once you put in that activation energy, right? Because they become more stable, they give off some energy. But our products are going to end up with a certain amount of energy. The same thing happens over here with our exothermic reaction. Just because it's giving off energy in total doesn't mean we don't have to put in some activation energy to get it started. Right, we put in some energy, break our bonds. Now our atoms are free to make new compounds, and then the reaction continues to proceed. And as those new bonds are formed, we're giving off a ton of energy here. Our products end up with less energy than what our reactants started. And the difference between our products and our reactants is the energy that's either given off and absorbed. So you can see that our endothermic reaction here, our reactants have less energy than our products, so we absorbed energy. That's an endothermic reaction. We took in energy, and that will feel cold because we're taking energy from our surroundings. In an exothermic reaction, you can see that our reactants here have more energy than our products do, and so we released energy. We went down in total in energy, and so that energy had to go somewhere. Well, it was given off into the surroundings. Okay, and that's what makes the surroundings feel warm from this. So overall, in our endothermic and our exothermic reaction, our endothermic reaction feels cold because it absorbs energy. Our exothermic reaction feels warm because it gives off more energy than it takes in. And so I hope that this helps to understand the energy in an endothermic and exothermic reaction.